All right. Hello, everyone. I hope you are doing well. This is just a short feedback on the second quiz you wrote. Essentially, every now and then I try to give feedback on quizzes you have written. So please, the issue here is that this is not something you should feed on for the purpose of exams. I'm just giving a feedback on your second quiz. Time did not allow us to do that in class. So I just feel I should give a feedback on it. All right. So that is the issue you must know. That is the disclaimer. Okay. Now, in every quiz, you must read instructions. Every form of exams, you must read instructions. It says that write your student ID on every page of the question paper. It contains 40 objectives. Circle the correct answer. Any change answer will be deemed incorrect. Then there was an instruction that says that unless otherwise stated, all hypotheses should be tested at 95% confidence level, which also means that, if we are testing it at 95% confidence level, it means we are testing at 5% alpha. So it says, unless otherwise stated, right? So it means that all the things you're going to do, you are going to assume 95% confidence level unless otherwise stated. And then the question gives the critical values for Z for one tail and then two tail. Now, there's the first part. It says that use the following preamble to answer questions 1 to 9. Suppose that in a recent Ghana Living Standard survey, 1865 out of 2246 randomly selected adults responded that instead of using traditional sources of energy like charcoal, they would rather use LPG in cooking. Before the survey, Ghana Gas Limited had made a claim that more than 80% of all adults use LPG in cooking. Now, remember that for you to state your hypothesis, you see all alternative hypothesis has no equal to sign, but all null hypothesis has the equal to sign. What I mean by has the equal to sign is that for all null hypothesis, it has the normal equal to, it has the greater than or equal to, it has the less than or equal to, right? But alternative hypotheses do not have that. So I remember I mentioned in class that when the question says somebody is making a claim and the claim does not have the equal to sign, it will be in the alternative. So here, Ghana Gas had made a claim that more than 80% of adults use LPG in cooking. So more than 80% means that the proportion of people is greater than 80% or 0.8. Which shows that the alternative hypothesis, which is H1 or HA, either of them is alternative hypothesis, should be proportion is greater than 0.8. Then the opposite of that, which is the null hypothesis, will be proportion is less than or equal to 0.8. That's all. Question 2. The hypothesis in question 1 above leads to what type of distribution? Now remember that since the null hypothesis is less than or equal to, right? Because of sampling error, we will allow for a little greater than, okay? Then after we allow for a little greater than, that is on our right-hand side, then we will shade the rejection region. So this means that it is a one-tail test. However, to be more specific, it's not only one tail, but specifically, it is a one tail, which is right-tailed, because we allow for a little greater than on the right. So this was a right-tailed test. Question 3. The test statistic is ... with a critical value of ... So here, because in proportion, there is nothing like standard sample standard deviation or population standard deviation. In proportion, we don't require T values, all right? We only require Z values. So here, the required test statistic is the Z value with a critical value of, now remember, The preamble of the question says everything is tested at 95% confidence or 5% alpha. So 5% alpha or 95% confidence when it is one-tailed. It's even in the question. Once it is one-tailed here, one-tailed, the critical value is 1.645. So question 3, Z value is a critical value of 1.65. Then what is the value of the test statistics? The question is asking the computed Z, all right? The computed Z. Now you just have to make reference to how to compute Z value for a proportion, okay? It is simply sample proportion minus population proportion divided by standard error of proportion, right? So in the question, the sample proportion, you have to compute it yourself. So sample proportion will be 1865 divided by 2246, you get a sample proportion. Then the population proportion is what is in the hypothesis. Then refer to the formula of standard error of proportion. When you compute it, you get a Z value of 3.55, positive 3.55. Now, number 5 says that the p-value of the test statistics is closest to. Now, the things is that if you are not even given a Z table, calculators can punch this. Calculators can punch this, right? Can punch, okay? So once it is positive 3.55, it means you look to the probability, because it's a positive, you find the probability to the right of 3.55, and your calculators can do this. So when you do it, you get 0.002. Now, what will be the conclusion on a null hypothesis? Remember that the computer Z was positive 3.55. The critical Z is 1.645. So if we were to draw the distribution, you will see that 3.55 will exceed 1.645. So it will be in the rejection region. So we reject the null hypothesis. Of course, you could have also used the p-value, Since we are testing at alpha of 5%, once the p-value is 0.0002 and it's less than 0.05, we can also reject the null hypothesis. State the conclusion, number 7, state the conclusion in simple, non-technical terms. Okay, what will be our conclusion? So remember, we have rejected the null. Okay, so once we have rejected the null, it means that our data supports the claim. Remember, the claim was in the alternative. So it means that our data supports the claim that 80% of all, more than 80% of all adults use LPG in cooking, because once we have rejected the null, our conclusion will be on the alternative, right? Number 8, if evidence from the population shows that the proportion of adults that use LPG in cooking are more than 80, what type of error will be committed in the hypothesis testing? Now, I told you guys that if you want to see whether the null hypothesis is true or false, all you need to do is that you have to compare the evidence from the population to your null hypothesis. Remember that the null hypothesis was proportion is less than or equal to 0.8. Now here, if evidence from population shows that proportion is rather more than 0.8 as per the question 8, it makes the null hypothesis a false null hypothesis because it is not in line with evidence from the population, all right? Now this means that it's a false null hypothesis. And remember, from our hypothesis testing in question 6, we rejected the null. So in that case, it means that we have rejected a false null hypothesis. It means that there is no error, all right? Anytime we reject a false null hypothesis, there is no error. Number 9, if evidence from the population shows that the maximum proportion of adults that use LPG in cooking is 0.8, what type of error will be committed in the hypothesis testing? Now, the word maximum proportion of adults means that the proportion is less than or equal to 0.8. The word maximum, it means less than or equal to 0.8, right? Less than or equal to 0.8. So if the evidence from the population shows that the thing is less than or equal to 0.8, When you compare it to the null hypothesis, it's also saying that P is less than or equal to 0.8. So that makes the null hypothesis a true null hypothesis in the context of question 9. So in the context of question 9, it is a true null hypothesis. Now remember from our hypothesis testing in question 6 that we rejected it. So in this question 9, it means that we would have rejected a true null hypothesis, and that makes it type 1 error. Type 1 error is when you reject a true null hypothesis. Now use the following information to answer question 10 to 18. Now the question says, since they usually eat late, the weight of night workers is usually measured by a company in order to give a proper advice on their health. For a sample of 100, so the sample size is 100, night workers, the average weight was found to be 185 lbs. Assume that based on previous data, the dispersion around the average as measured by variance. So this is a very key word, as measured by variance. As measured by variance is 15625. Remember, in our calculation, we would use standard deviation, not variance. So straight away, you must find the square root of 15625, and that would be your standard deviation. So note that one of the managers claimed that there is no need to measure their weight again, since it costs the company huge sums of money, and that the average weight of all the workers is currently 210. So the manager is making a claim that the average is equal to or is currently 210. All right. Number 10, identify the null and alternative hypothesis to test the claim. So the person is making a claim that the average is 210. The average is 210. What it means is that will feature in the null because the equal to sign is there. The equal to sign, you've got the average mu, the average is 210. All right. So because it has the equal to sign, to reflect in the null. So here, the null hypothesis is mu is equal to 210. The alternative, the opposite of the null, which is the alternative, is mu is not equal to 210. All right. What type of hypothesis test is this? Obviously, because it's the equal to sign, we will allow for a little less than, we allow for a little greater than. So that makes it a two-tailed test. Number 12, for a two-tailed test, remember that for a two-tailed test, all right, here, because the question says that based on previous data, we know the variance, which I've told you, change it into standard deviation. Okay, I've told you that already. So based on previous data, we know the standard deviation. When you find the square root of this variance, I'm sure it will be 125 or something. Yes, I'm not too sure, but it should be around that figure. If I'm wrong, just do the correct one. So you find the square root of 15625, that would be the variance, sorry, the standard deviation. And the question says that we know it's based on previous data. It means that population standard deviation is known. And once population standard deviation is known, the required test statistic is the z-value. And because it is two-tailed, the absolute value is what? The critical value is 1.96. All right. The question here was absolute. Without the word absolute, you would have written plus or minus 1.96. Okay. What is the value of the test statistic? Please go back and refer to your formulas on how to compute the z-value, okay, of the mean. It is sample mean minus population mean, okay? Sample mean minus population mean, okay? Divided by standard error, okay? The standard error. And you know standard error. Population standard deviation divided by square root of sample size, right? So in the question, the sample mean was 185. The population mean is what is in the hypothesis, which is 210. Sample size is 100, and then standard deviation is square root of this figure. So when you fix everything together, you're going to get the z-value to be minus 2, right? You're going to get the z-value to be minus 2. And you say, what is the p-value? So because it's negative, okay, you would compute the p-value to the left of minus 2, okay? And you get 0.0 228, all right? But because it's two-tailed, if we were to use this for hypothesis testing, we would have multiplied the 0.0228 by 2 because it's two-tailed, okay? But then the question was simply asking the p-value of the t you have just computed up there. For that purpose, you just find it to the left because it's negative 2.0. The z is negative 2.0. You find to the left of negative 2.0, you are going to get a p-value of 0.0228. What will be the conclusion of the hypothesis? Okay, remember, it has a critical z of minus 1.96 to the left, positive 1.96 to the right, okay? So because our computed z of minus 2, okay, if we do the distribution, because the critical value on the left is minus 1.96, and then our computed z is minus 2, it is less than the critical value of the left tail. So technically, it falls into the rejection region, okay? So reject the null hypothesis. 16, state the conclusion in simple, non-technical terms. So here, we have rejected the null hypothesis, right? So here, the answer is B. There is sufficient sample evidence to warrant the rejection of the claim, because the person's claim was that the average was equal to 210. But once we have rejected it, it means that we have found sample evidence to reject the claim or the null hypothesis made by the person. 17, if evidence from the population shows that the average weight of the worker is 210, what type of error will be committed in the hypothesis testing? What type of error is committed? Now, remember that, you see, if evidence from population shows that the average is 210, if you compare it to the null hypothesis, it makes the null hypothesis true, right? And remember, from our hypothesis testing, we have rejected the null hypothesis, which in the context of question 17, it is true. So when you reject a true null hypothesis, you have committed type 1 error. Number 18, if evidence from the population shows that the average weight of the workers is 185, what type of error will be committed? Sorry, the average weight of the, if evidence from the population shows that the average weight of the workers is 185, what type of error will be committed in the hypothesis testing? Now, if evidence shows that the thing is 185, okay, this evidence from the population is in contrary with the null hypothesis, because the null hypothesis says that it is equal to 210. But then in the context of question 18, okay, evidence from the population shows that the average is rather 185. So 185 is not the same as 210, right? So it means that evidence from the population shows that the thing is not 210, all right? It's not 210. So that means that it makes our null hypothesis a false null hypothesis. And remember, it was rejected. So in the context of question 18, we have rejected a false null hypothesis. That means that there is no error. Number 19, suppose management wishes to assess the effectiveness of a training program aimed at improving employees' IT knowledge. They administered the same questionnaire to the same set of employees before and after the IT training program. The questionnaire obtains scores on the level of, on employees' level of IT knowledge. Based on the scores from the questionnaires, the most appropriate statistical test to perform is, question 19 was very obvious. We are testing difference in average knowledge before and after an event. It means that the samples are paired. There is the same group or the same sample. All right, they are matching. So this is paired samples t-test. Now use the following data. Suppose the following data relates to the scenario in question 19. Use it to answer question 20 to 24. Now the point estimate for the paired difference. Those of you remember from class, we want to find the point estimate for the paired difference. You just find the difference. So 3.0 minus 3.3, you write the difference down. 5.6 minus 6.8, you write the difference down. So we do it for all the 1, 2, 3, 4, 5 sets of figures, right? So when you are done, the difference is you just find the mean. You sum all the differences and divide by 5 because they were 5 pairs. When you do it, the point estimate or the average sample difference is minus 0.70. 21. If management wishes to test the hypothesis that the training program has been effective, the appropriate statement of hypothesis will be now. If the training program has been effective, it means that the scores before, okay, must be less than the scores after. The scores before must be less than the scores after. In other words, the average of the difference must be negative. Why must it be negative? Because we are subtracting the scores after from the scores before. So it's like all the scores before here minus all the scores after. So if all the scores before are smaller than all the scores after, the average difference must be negative, all right? Why am I saying so? Because if the thing has been effective, their knowledge after the program must be greater than their knowledge before. Or in other words, their knowledge before the program must be less than the knowledge after, all right? So the average difference must be negative or it must be less than 0. And because it has the less than sign, it will feature in the alternative, right? Then the null is that the average difference is greater than or equal to 0. So the answer is A. Number 22, the value of the required test statistic is closest to the value of the required test statistic is closest to. So here you're supposed to compute the t value, all right? So here the population average difference is 0. The sample average difference is minus 0.70. Then you know the formula for standard error of paired sample t-test. So when you do it, the t value is average difference of the sample minus average difference of the population divided by standard error. All right, so when you do it, you get minus 1.397. Now, the question goes on to ask the critical value. So here we're supposed to read the T table that has been provided at the end of the question paper, right? So here, you are going to read, so you just have to read 0.05 one tail, okay, against a degree of freedom of 4. Why degree of freedom of 4? Because the number of pairs were 5. So for paired samples, the degree of freedom is number of pairs minus 1. So that makes it 4. So when you read the critical value, you are going to get minus 2 points. You get 2.132, but remember, this is a left tail test, okay? It's a left tail test because the null hypothesis is greater than or equal to 0, but we allow for a little less than, so it's a left tail test. So now you impose the negative on the critical value, the critical t, then we have negative 2.132. 24. If evidence from the population suggests that the training rather make employees worse off in terms of their knowledge, ... may occur because the computed test will lead to ... of that. So here, if the training program was rather worse off, it made them worse off, it means that the average before must be, sorry, the scores before must be greater than the scores after. So it means that the scores before minus the scores after, the average difference, you must get positive, which shows that the null hypothesis, the average difference must be greater than 0. So if you compare it to the null hypothesis here, it makes this null hypothesis true, okay? So here, that means that null hypothesis is true. Now remember, the computed t was minus 1.397. Critical t was minus 2.132. If you draw the diagram and you fit it in, you see that it will fall within the acceptance region, okay? So it means that we would have failed to reject a true null hypothesis. That means that there is no error. So here, no error will occur because we will not reject the null hypothesis. So the answer is C. Use the following preamble to answer 25 to 27. Suppose Management of School of Business wishes to determine whether the academic performance of females group 1 is higher than that of male group 2. The only available information to them is average GPA of 302 female and 212 male. 25. The most appropriate statement of hypothesis will be, so we are testing whether the average of group 1, right, is higher than the average of what? Group 2. So that means that mu1 must be greater than, so that means that mu1 must be greater than mu2. In other words, mu1 must minus mu2 must be greater than 0. Okay, mu1 minus mu2 must be greater than 0. Okay, and because it has the greater than sign, that will be your alternative. All right, and then the opposite is the null, which says that mu1 minus mu2 is less than or equal to 0. So the answer is C. Now, because we are testing the average for two separate groups, okay, we are going to use independent samples t-test. T-test because the only information we have is their average. We don't have information on the population standard deviation. So we use T for independent samples t-test. 27. In order to accurately perform the test in 26 above, the sample size of the two groups must be the same. The answer is false. Okay. The only test we do for two population parameters that the sample size must definitely be the same is paired t-test, because the scores before must match the scores after. Apart from that, all the other ones, we don't need to have the same sample size in the two groups. So the answer is false. Use the following preamble. The following figures relate to advertisement caused by 10 firms and the sales they made in millions of Ghana cedis. Use it to answer 28 to 40. 28. The value of correlation coefficient R is closest between sales and advertisement is closest to, now correlation, okay? This one, it was just calculator. You see, start saying, you don't need to spend time calculating it manually. Calculator can compute correlation coefficient for you. I don't know why you want to do it manually. Feed the calculator, just punch and find R. Okay, if you want to do it manually, to be n sigma xy minus sigma x sigma y all over the square root of bracket n sigma s squared minus sigma s all square bracket close, bracket open, n sigma y squared minus sigma y all square bracket close. Then we have a big square root at the denominator, right? But it's a long procedure. So just punch calculator and get it. So in punch calculator, the correlation coefficient is simply 0.69. Number 29, based on answer in 28, the coefficient of determination R square is what? Now, if R is 0.6, now what is R square? You just square the R. When you square 0.69, you're going to get 0.4761, okay? All right, so it means that the R square is 0.4761. Remember, R square is the variation in the dependent variable that is explained by the variation in the independent variables or the determining factors. So the answer was C. Approximately, if you convert the decimal to percentage, you get 47.61. So approximately 47.61% of variation in sales is explained by the determining factors. That's C. 30. The hypothesis to test simultaneous significance is, now remember, in class, I taught you that simultaneous significance means that all the variables together, they explain, all the independent variables together, they explain the dependent variable. In other words, the R square is significant, right? So the null hypothesis to test simultaneous significance is that null hypothesis R square is 0, alternative R square is greater than 0. This is quite special because obviously when you see R square is greater than 0, you expect the alternative to be R square is not equal to 0, but that's not the answer. We impose the non-negativity because R square can never be negative, right? So the answer is null hypothesis R square is equal to 0, alternative R square is greater than 0, right? Suppose the p-value of the F statistics is 0.002. at 5% significance level, we can conclude that. So you see, if your p-value is 0.002 and your alpha is 0.05, it means you are going to reject this null hypothesis. All right. That means that we can conclude using the alternative. That means that R square is what? Significantly greater than 0. So the answer is A. 32. The estimated regression equation of sales on advertisement cost will be. Now here also, I did not expect you guys to solve it manually. Just use calculator. So feed the calculator. Use sales as your dependent variable. So if you feed the calculator, sales will be Y, advert cost will be what? X. Okay. So when you punch it, when you find the value of A, the constant, you are going to get 5.669. Then the slope coefficient will be what? The beta will be 1.004. By formula, A is sigma y over n minus B sigma x over n. And then B is n sigma xy minus sigma x sigma y all over n sigma x squared minus sigma x all squared. But calculator can point this. Why do you waste your time? Okay, so here, the A was 5.669, and then the beta was 1.004. So your regression equation will be sales is equal to 5.669 plus 1.004 advert cost. Remember, sales was the dependent variable because it says estimate the regression equation of sales on advert cost, right? 33. Based on your answer in 32 above, what would be the residual if for advert cost of 10 million, if actual sales is 18 million? So all you needed to do is that you have to put 10 million of advert cost in this equation. All right, you have to put 10 million in this equation. You put 10 million where the advert cost is. When you punch, you get your predicted sales. Okay, you get your predicted sales to be, I don't know, 15 point something, I don't know. So you get your predicted sales, okay, to be a certain figure. So if you want to see residual, it is actual Y or the actual sales minus the predicted sales. Okay, so if the actual sales is 18, if you subtract the predicted sales that you do from the 18, you get a residual of 2.29 million. 34. Suppose the standard error of the intercept is 0.196. That of the coefficients of the slope is 0.235. Their respective t statistics will be this and that. Remember, t statistics is the coefficients divided by standard error. So if you divide 5.669 by a standard error of 0.196, you get a t of 28.92. If you also divide a beta coefficient of 1.004 by a standard error of 0.235, we're going to get a t of 427. Remember, t is coefficient divided by the standard error of the coefficient, right? 35. The hypothesis to test significance of the individual regression coefficient will be. Now remember, we are not testing joint significance. We are testing individual significance. So it means that each of the null hypothesis is that each of the beta is equal to 0, or each of the beta, the alternative will be each of the beta is not equal to 0, right? And here it is, we use the is not equal to because beta can both be positive or negative. So the answer is D, all right, D. 36. Assuming critical values of plus or minus 2. Based on your answer in 34 and 35, we can conclude that the coefficient of the intercept is, and that of advert cost is, okay? Now remember, all their critical values were greater than 2. This one is greater than 2, positive 2. This one also greater than positive 2, right? So if we draw the distribution, if it occurs, this is a two-tailed test actually, but then this, the hypothesis will be occurring at the right tail. So 28.92 is greater than 2, 4.27 so greater than 2, all right? So it means that we are going to reject the null hypothesis that the coefficients are not significant. It means that we are going to conclude that the coefficients are significant. So the two of them, all of them were significant. So the coefficient of the intercept is significant. That of the advert cost is also significant. So the 36, the answer is A. Now remember, in 37, the question is asking the final regression equation. Remember, for final regression equation, okay, we write only the significant ones, and all of them happen to be significant. So the final regression equation, all the coefficients will come again. So 37, the sales is equal to 5.669 plus 1.004 adverse cost. So the answer is the same as the estimated one. 38, based on your answer in 37, change in sales for a change in advert cost from 10 million to 12 million is closest to. So first of all, you just needed to put 10 million here. You find your sales. Later, you put 12 million also there. You find your sales, right? So you subtract the first answer from the second answer to see the change in the sales. So the answer is A, 2.008 million. 39. Evidence from the population suggests that advert cost is irrelevant. When we say advert cost is irrelevant, it means that it is insignificant or its beta is equal to 0. Now, this evidence from population is in line with the null hypothesis that says that the beta is equal to 0. So in the context of question 39, it makes the null hypothesis a true null hypothesis because it is in line with the evidence from population. But remember, before we concluded that the thing was significant, it means that we rejected the null hypothesis. That means that we have rejected a true null hypothesis, and that is type 1 error. Finally, which of the following is, number 4, which of the following is not a key assumption of regression? A, there is no serial correlation in the error term. It's a key assumption. Remember, serial correlation or autocorrelation is the same. So it's a key assumption. There shouldn't be autocorrelation or there shouldn't be serial correlation in the error term. It is a key assumption. B, the variance of the error term is constant, which also means that there is homoscedasticity. Okay, so B is also a key assumption. D, the error term should be normally distributed, so a key assumption. But the C, the independent variable should always be measured on interval or ratio. It's not a key assumption. All right. Independent variable can be qualitative or quantitative. Okay, so it's not really a key assumption. Even though we didn't do qualitative independent variable, it exists. Okay, so the C is not a key assumption. So the answer is C. Now to wrap up, I said I'm just giving you a feedback on the quiz. Please, this is not the exams question. Don't go and put your heart on it. Okay, don't go and put your heart. I'm just giving a feedback on your second quiz. Try to help you understand some of the concept better, why you had some correct, why you had some wrong. So on this note, I wish you guys all the best, and then all the best.